Okay, so now I've got these basic views set up for the plan and the section. I want to get some other views set up for the, particularly the interior work that we're going to start looking at as you start to put your design in. So you can see I've got some perspective views that I've set up previously. I'll just open up. And they can be placed on sheets. And then we've got some axonometric views that again can also be placed on sheets. So I might start with the perspective views and also just remind you how you can create perspective views really easily using the camera tool. So either on the view tab or going under 3D views and then camera. And then we can choose the camera location and then where it's looking. So in this case, I'll place the target maybe just a little bit closer to the camera than what I did before. And you can see something that might have happened to you as well, that it's cropping out the things that are in the distance. So here you can see the view stops there when I'm moving the cursor. And I'll show you that if I go back to the ground floor, we can then see why. So you can see there with the cone of vision, it's only going as far as that first flight. So I can extend it out. But now that I've clicked to the side, I can't see the camera anymore. So to bring that camera up again, I need to leave that ground floor view open and then go down and right-click on the new view name, which is 3D View 3, and then choose Show Camera. So how do I know it was 3D View 3? Yeah, it's a new name, that's right. So I already had 3D View 1 and 2, and always make camera views with that name, 3D View, and then the number. So 3D View 3 is the last one. And now I can see the camera again, and then simply extend that by stretching that cone. So now if I open 3D View 3 again, now I can see everything off into the distance.
So we don't drag the purple dot on the camera on the floor plan?
No, that's right, yeah. Yes, that does something different. That moves the target, or actually rotates the target, but it doesn't affect the field of view. Yeah. But we can use it to rotate it. Okay, so I've got my perspective view set up. Now I want to put that onto a sheet. So I'll go and make a new sheet again, same as before, right-clicking on Sheets All, new sheet, and then select the same title block, click OK, and then just as you did for the section in the plan, I can drag that view from the project browser and then click to place it on the sheet. And now you can see it's fairly small in relation to that sheet. So how do we change the size? Yeah, so size crop is the right idea. Yep. We don't need to double click. So just with the view selected, in perspective, you'll see size crop comes up on the ribbon there. So when you click size crop, you'll see that down the bottom, you've got two options. And it's really, really important. If you're just trying to change the size on the sheet, you need to change it to scale, not field of view. So make sure you choose the scale option. And then you can simply type in the size you want. Okay, so in this case, I know that we have an A2 sheet. So what's the size of an A2 sheet? Something you should know. Okay, so maybe write it down. 594 by 420. It's easy to remember as long as you remember the size of an A4 sheet. Do you all remember the size of an A4 sheet? Okay, you should know that off by heart by now. Yeah, 210 by 297. Okay, that's a number you should all remember. And then you can work out all the other page sizes by doubling the smallest dimension. Yeah, it's something. Okay, so it's something you should remember because you'll need to work with these numbers all the time. Okay, so we know the width is 594. Okay, so if the moment the width is 150, the total width is 594, maybe half the page is about 300. So anything less than that. So maybe 200 maybe 250. So I'll try 250. And then if I click to the field on the right, to the height, you can see it changes automatically because it has locked proportions. So if I change one number, the other changes in proportion. So that's it. I'll click OK, and the view changes size. Okay, so perspectives do not have a scale. Even though that option says scale, they don't have a scale. They can't have a scale because objects in the foreground are bigger than objects in the background. In other words, they change size, so they don't have a consistent scale.
And if we do select the other option in the field view, so that actually...
That would change the border and change what we see. So it would crop things out or bring the crop region out so we can see more, and we don't want that. That's adjusting the camera, which is a different thing. Okay, so we get the tag just like any other view, and so that way you can easily set up perspectives and start sketching, if you need to, over these perspective views. And I was just talking to a guy who's doing his PhD. It's in the uni right now, and will soon be one of the, well, he's already lecturing there. He did all of his perspectives throughout his entire degree, from the beginning to the end, this way. He was taught how to do them by hand, setting up 1-point and 2-point perspectives, which is usually all you need, and then realised that you can get all the detail by modelling in a basic setup like this to get particularly to establish the sizes, and then tracing over. He did all his perspectives by hand, but he traced off computer-generated models. Yeah. Yeah, yeah, that's right.
So how can we actually do it to the 2-point or 1-point? How can we select?
Oh, okay, so that's just a matter of understanding what 2-point and 1-point really are.
So
Okay, so 1-point. So yeah, have a look at the history of perspective. It's really interesting because I think it's taught wrong. Most people who teach perspective drawing don't understand photography very well, and don't understand that perspective drawing actually evolved at the same time as the lens, if you look at the history of the Renaissance and what happened afterwards. And there's a lot more to it than just 2-point and 1-point. But 2-point and 1-point really only make sense with rectangular buildings. And they mostly were up until that era. That's why it's easy. So if you go and make a camera, in this case, this is a rectangular building. So with a building like this, if I have a camera point over here and keep the target in line with my camera, or in parallel with those floorboards you can see there, that's a 1-point. If I rotate the camera, right, so it's not parallel with those boards, and then open that view again, that's a 2-point. It's that simple. And so all of that setup you do, making different vanishing points, really is just because you have walls or things that you're projecting that are at different angles. Now, if you orbit the view, I'm going to change the angle there, so I'm looking slightly up. Notice how now the walls look like they're sloping, right, because they're going to a different vanishing point. So that's 3-point. It's that easy. 3-point is just when you have, and you don't get this when you're drawing. Often people will just make all the vertical lines parallel, which is totally unnatural. Right? That's not what your eyes see. It's not what a camera sees. But people, they don't even realise they're fudging it. But when they're drawing, often will do that when they're looking up and still try and make all the parallel lines.
When you're looking up or down, it's 3-point.
Yeah.
And the side, and the
Yeah.
yeah.
Yep, that's it. So imagine the poor old photographers, for years and years they had to adjust their photos to do what the architects thought they should have, which is straight or parallel vertical lines. And they used to use all these different plates and things to bend the photos to make them look the way that the architects wanted. And a lot of that was because architects were trained to draw in this way of working it out with vanishing points, which is what the Renaissance people worked out after a little while, but it's not how they started. And they probably did start by looking at the way lenses work, and then took it from there and came up with the rules afterwards. If you're interested, a guy called Alberti, after Giotti, developed a lot of these rules, and then that's how perspective drawing was taught. So, anyhow, what I'm saying is, if you then learn how perspectives work when you're working with a computer, then you'll understand more about the technical aspects. and by also learning about how cameras work, again, it will give you a much better idea how perspective drawing works. Last thing I'll say, if you're really interested, there's a film called Tim's Vermeer, which goes through all of this theory, and Tim's Vermeer, it's based on the work Tim's Vermeer, you know, the Dutch artist Vermeer. Yep. And so that's based on the work of an artist called David Hockney and his friend who was an Italian mathematician. I always forget his name, but they did a lot of work on this over the last decade or so to basically, you know, correct the history of what people thought about the way perspective drawing and lenses, the use of lenses and concave mirrors evolved over time, which I think was really interesting and actually just confirmed what a lot of people I know who work with these tools already suspected, which is that hand-drawn perspectives are great. It's good to know about those things, but the understanding you get really is only going to be complete when you know how camera works. But it's good if you're already thinking about that, that's great. And then, yes, you can get some 1 point, 2 point perspectives, whatever you need, and set those up onto sheets, which is what I'll do again now, back onto the sheet. We'll put another perspective over to the right. And because I've just explained, I can easily make that same size by selecting the view, going to size crop, and remember scale, and then I can type in the width there, make it 250, and we know it's exactly the same size. Okay, so at this stage, that's probably as far as you need to go. You don't need to render. In fact, you probably wouldn't want to render these perspective views because it's going to interfere with the design process. At the moment, all you should be doing is sketching, and having the existing walls and the other things set up for you can help you a lot with that. And also, one thing I should show you though is how to adjust that perspective view. So to now adjust that so that I can see something different, I don't want to change the size on the sheet. So I'm going to go back and open that view up. So maybe I want to see some more in there. So I'm going to use the navigation wheel and then maybe use the walk option to bring my camera back a little bit. I've gone into a wall, so I'll walk forwards again. So that's right, so that's going to show something interesting, that I can't just keep walking back and back because I will hit a wall. We could hide the wall, but maybe a better way of seeing more is to use the perspective tools, in other words, to bring out the field of view to show more. So I could even bring it over to the right here where I'll probably see some other, well actually I don't have too much on that wall, but if we had more on the wall, obviously we'd see that. So maybe I'll go and put a person or something, because I don't have the window there. I'll just put someone from the entourage in there. Remember from before, I put an RPC family. Here we are, one of the people. There we go, Tina, that'll do. I'll stick her over here just so that you can see she's where the window would be if there was a window there. So back into that perspective, and again to see her, I can eventually, if I drag this out enough, see the person. And that's an important thing. When you're drawing your perspectives, you'll sometimes want the field of view to be brought out to show more, in the same way that a zoom lens works, essentially. So I've done that, but now if I go back to the sheet, you can see the view's much bigger now because I've adjusted that field of view. So how do I get it back to match my previous view? Same as before? Exactly, that's right, spot on. So I can select it, go to size crop, and make sure I choose that scale option, and I'll set the width there again to 50. And it won't change what's inside that view, it's just going to change the size on the sheet. Okay, so this one is higher, but it's at the moment the same width, so maybe in there, if I want to match this height now, I need to know what that is, so it's 120. So if I go to size crop again here, scale lock proportions, and I can change that height to, again, 120. And there we go. Okay, Okay, so it's a huge thing when you are drawing in perspective, having this setup done for you. I know if you're the master of perspective drawing, this might seem easy to draw by hand, but I mean, I do quite a lot of, I still draw in perspective quite a lot, and I still find the setup and getting all the exact distances, projecting off the plan to be a lot of work, so this can save you from doing all that.
Well, when you release in shop when you draw perspective,
Yeah, if you can get this set up, it's going to make it, much faster, so you can go in and start showing the perspective drawings from the very beginning.
No, they don't mind that they
No, they want you. They're fine. They know the real process, so they're happy for you to use computers. But I know some lecturers. I've had people before force me to show them all the setup lines I'd done off my hand-drawn perspectives, and luckily I knew how to go and do those. But it's pointless, really. As long as you understand perspective, you don't need to do that old-fashioned setup that people used to make you do. So then now I can get some other types of 3D views, and they can also be useful. So before I showed you that you can use that great new tool in Revit, which is this section box tool, also selection box. I say section box because that's really what it's making, but you can see the tool is called selection box. So if you missed it, I'll just show you that again. In this case, I'm going to select my stairs on the plan. Oh, no, actually, sorry, let's go to the section. Since we've done the upper stair, I'll go into my section view, and I'll select the stairs. Well, yeah, that's right. You've got to select something. And then I'm going to use Control and select the other stair as well. And, yeah, that'll be enough. So then I'm going to click on that tool, Selection Box. And what does it do? Makes a new view just showing my stairs. And that's a great thing. I can still adjust that, though, using the section box. So that's this box that goes around my view, or around my objects, and I can bring that up to show maybe the handrail there. I can bring it out using, again, these arrows. If you orbit, sometimes that makes it easier to see where they are. So there's the arrow on the right, and I can bring that out and see more of the floor, bring it to the left and see more of the floor on that side. Well, there's a wall in the way, so maybe I'll bring that back to the right. Oh, actually, maybe I want to see that wall.
Is this like an isometric?
It is. It's very similar. That's right. I'll actually explain what those are. So a lot of people would just call this an isometric. And I'm going to say, technically, they're not wrong. Because isometric is one of those terms, again, that really only makes complete sense when you're talking about rectangular buildings. That term iso means equal angle, basically. Yeah. So here, if you click on the corner of your cube, you get equal angles. Left, front and top are all equal. In other words, it's a 360-degree circle, and each of the angles inside those corners there will be 120 degrees. But then you might have heard when you're told how to draw a perspective that you use 30 and 60. You ever come across that? Yeah. That's right, and that's normal when you're drawing, because you start with the horizon line, which is your horizontal line, and then from that 0-degree horizontal line, if you measure up and to the left to create this line, that's 30 degrees. And then from there to the vertical axis is 60 degrees. So that's where the 30 and the 60 come from. But it still all adds up to 120. So again, that's why that ISO term is used. ISO basically means equal in ancient Greek or something. So then if you go to the, again, the angles in between, technically that's not an isometric because these angles are no longer equal. But like I said, in a way, technically, they are all isometrics because it's only not equal because it's not in line with the angle of the building. If we had a building with walls at different angles, we can decide which line or which wall our angles are measured from. But I don't want to confuse you too much. Technically, they're all isometrics, but we'll just say these ones on the corners, they're your true isometrics. And then, if you orbit, it's no longer equal angles, so no longer technically an isometric, So a better term for it is axonometric. So axonometric simply means a vertical axis. Okay, so you can see there, in Revit the angles always are vertical. Even if you're drawing from below, you'll always have vertical lines on the side of your walls, and the box there, it's always perfectly at 90 degrees.
How is it different from isometric again?
So the angles here aren't equal.
Or the angles?
Yeah. Okay, so any of these other angles, they're all axonometrics. The technical term is not actually axonometrics, it's orthographic. So, yeah, I know there are lots of terms. There aren't that many though. Yeah, vertical axis is axonometric. Yeah, well, axonometric could be iso as well. They can be equal or not equal with an axonometric. But then what you'll see in Revit, they say they don't call them axonometrics. They call them orthographic. But then you might hear some people use that term for plans and sections. What they really mean is orthogonal. Slightly different. Yeah, so orthogonal is a plan or a section view or an elevation view as well, because they're projected at 90 degrees to the ground plane. So that's an orthogonal view. Orthographic means projected at 90 degrees to the picture plane. So that's technically any view that isn't a perspective. Plan, section, elevation, or any of these. They're all orthographic views. Just a technical thing, but you'll see that comes up in the software quite a lot, because guys who make this software, they're not architects, they're not graphics people, they don't know these things. So they have to learn them from scratch, and they're programmers, so they go and learn it properly, and they go and learn the technical terms. Right? So they use those terms in the software.
What did you say? Offensive? No.
So orthographic. Yeah, you would have, yeah. So, and that's a good thing, because I think you're lucky here that you're still taught how to draw these things. Often they'll just tell you, go off and work it out for yourself, really, which is what a lot of people do. And then you'll learn perspective drawing, but then not how to draw these orthographic 3D views, which in some ways are more useful for design, because in these views, the size is consistent. Whether it's on one level or the next, it's not going to change because it's in perspective. So that's an easy thing to put on a view, to put on a sheet now. I can go down and make maybe another sheet. And so, what's the view called? Well, I know because I didn't rename my views. It's called 3D. So, something to watch out for there. If I click on the house now, what's going to happen? Nothing.
It just says axonometric. That means you made it. Did you save it like that, or
it gets saved automatically?
Oh, okay.
Yeah. Now, if I click on the house, notice it's not doing anything because I haven't renamed this view. That's the default name. So I've got to rename by right-clicking, and I'll give it a better name. So we'll call it axonometric stair. Well, not before you go back, but before you try and use that tool again. So yeah, so if I click on the house now, it will make a new view because I don't have that default name anymore. So it can use it again.
But it created a default one.
Yeah. And that's something that can be really useful because you'll sometimes want to have a view where you can see everything. So it's a really good trick there to try and clear that name. So here, I can rename it again, and we'll call it axonometric building. So I'll go and put that onto my sheet with the other view. So I've got axonometric stair, axonometric building. So I'll start with the building actually. I'll just drag that across and place it on my sheet. No problem, that fits pretty well. I'll go and drag the stair view across and place that to the right, and that is obviously going to be much smaller because it's only showing part of the building. So how do I make that take up more of the sheet?
So you double click?
Oh, you can. I'll show you that now. I was going to come and show you that afterwards, but we'll have a look at it now. So if you've been double clicking on these views, what you're doing is activating the view. And then it's just as though you're working in that view. I can orbit the view.
Isn't that better, or is it?
It's, yeah, it can be good, yeah. I've got all the different view controls that I have normally, so I've got the different display options.
Oh.
So it's just like you're working in the view. I can even draw in here, so I can go and draw some walls. Oh, of course. Now it's telling me it's not visible, so I'll undo that and I'll
But
just
will
draw.
will that change on the plan as well when you add here?
Oh yes, of course, yeah.
Okay.
So there we are. So I've just drawn my wall and made sure it's on the ground floor. And so we would actually see that even in the 3D view. You can just see it there. There's my wall. And of course, yeah, like you're saying, it will be in the plan. But notice how I'm on the sheet and it's still highlighting that view.
Yeah.
So it's still active.
Okay.
So to get back to the sheet,
Escape?
no, unfortunately what you've got to do is remember to right click and then deactivate view.
Oh. Okay.
No, so because you can't really select it.
No.
No, that closes the view.
That's
Yeah,
all.
no. Yeah. So the best way is, yeah, right click and then deactivate view. And now if I go to my sheet with the floor plans, yeah, of course I'll see that wall. That was the one I just drew there. Okay, so I've got this new view on my sheet and I want to make it bigger. So how do you think we set the size of a view like this? Remember, it's not a perspective view,
No, the video
same as the plans. It's got a scale. Axonometric views and isometric views, they're just like plan and section views.
So you just drag it? Oh.
You just set the scale. So you can do that in properties.
Okay.
It's that easy. Just like your perspectives and plans, though, you can, again, I'll activate the view. So you can hide things, just like in any other view. So if I don't want to see that wall, I can hide it. Oh, no, it's a property of the view. Yeah, so even before I named it, Revit knew it was an orthographic view. So it's not a perspective. So if it's not a perspective, then you set the scale to set the size. Oh, yeah, for other views it will. Plans and sections it will. But this tag is set not to show the 3D views, even though it does have a scale. Yeah, it's just the way they are. Okay, so that's really the last major thing I want to show you, that you can have the other types of 3D views. The perspectives, of course, with size crop you can set the size to anything you like. And then the orthographic, or let's call them axonometric views, you can easily set the size with the scale. And they're a really useful thing. I really like designing with 3D views. Even though some people, I mean, all the famous architects you would have ever heard of, would have designed with just plans and sections. So you can easily do all of that. But again, 3D views useful for a lot of people. So the last thing you might have seen me just do there is to hide that section box. All those extra lines are making it harder for me to read, so I'm going to select that. I've activated the view, so now I can select this and then hide in view elements. That makes it a bit easier to read. And then to go back to the sheet, again, remember, right click and deactivate view. And so maybe just to make it really crystal clear why we're doing all this setup, it's so that you can then go back and start working on the things you want to add as part of your design. So these are all things you should be pretty comfortable with. Putting in walls, for example. I can draw some more walls now following around that stair. Let's pretend I'm going to keep the stair for the time being. No, just work in the one you've got. Yeah, that's it. That's the whole point. So, I mean, you might keep a copy of, the version that you've got if you want to go back to it. But otherwise, no, just keep drawing in the one file. So we'll look at the ways of breaking up existing and new afterwards. I'll do a new video for that. But I just want to give you an idea about setting up the views to start with. So now, if I go back and look at those sheets, you can see in my perspective view, straight away I've got those new wall positions. And then of course in those, especially the axonometric view, again we can see those new walls I've just added really clearly. So just to make it clear, you can easily set the views up before you've got any idea of the design. And it's a really good way of experimenting and seeing what happens when you do something like I've just done there, enclosing the stair. Is going to have a really obvious impact on these views. And we can see the results straight away. That's a really big advantage with Revit, as opposed to, say, AutoCAD, where you would have been drawing in each view every time you make a change. Okay, so I'll give you some time to set up some other views, make sure you get them onto sheets, and then we can have a look at some ways of managing the new and the old, the existing and proposed. But I'll give the screens back too.
So how many views do you think?
I'll at least get a perspective and a